Dr. Latham's research focuses on a wide range of ethical and legal issues related to healthcare and biomedical research, including genetic testing, reproductive technologies, and end-of-life care. Overall, Dr. Latham's qualifications, achievements, and dedication to the field of bioethics have really earned him a reputation as one of the leading voices in this critical area of inquiry that we really wanted to explore in this symposium, really at the cross-section of humanities, speaking broadly, and the STEM research and sciences. So give it up for Dr. Latham.
Great. Thank you very much. And thank you for having me. Nice to meet you. I'm going to speak today a little bit, I'm going to take advantage of the research and theme and talk a little bit about research and ethics, or if you like, research integrity. But not only research integrity, some kinds of structural things about the way that STEM research in particular is organized at universities that I find kind of troubling. So let me start out with not some ethics examples, but some non-ethics examples of some troubling things that are going on in STEM research. In 2005, a Stanford University professor named John Ioannidis published a paper called Why Most Published Scientific Findings Are Wrong. And this has now become, I think, the most downloaded paper in STEM. And here's what he said in this paper. Again, this is 2005. He says, lots of people who do research are not well trained in research methodology. So they do things like they wade into their data, they find some interesting correlation, and then they back a hypothesis out of that. And then they research the hypothesis, and not surprisingly, the data confirm the hypothesis, right? Because they've thought of their idea after having looked through their data. And that is an excellent way to get an incorrect result, some result that's just a result of some kind of statistical anomaly or coincidence. In addition to this problem, which is really, and I will say it's a particular problem in medical research, because most medical researchers are MDs only. And in no part of your MD education do you get introduced in any complex way to research methodology. It's not part of the curriculum. Right? So there's that issue. So a few published research findings, particularly in medicine, are going to be wrong because people are incorrectly using their data. Then Ioannidis says there's something else that happens in the United States, but also around the world, which is that when some approach to some problem, any kind of problem in STEM, starts to look promising, the funders all glom onto it. NIH starts saying, they start soliciting people to do research on a particular approach to a medical problem. Or the National Science Foundation starts saying, we're taking proposals for people who want to address this set of issues. And here are the methods that we're interested in funding, and so on. So funding comes in vogues. And as Ioannidis put it in the paper, once you have more than 20 groups taking the same kind of approach to the same scientific problem using sort of ordinary statistical significance standards, one of those 20 is going to come up accidentally with a significant finding. Even if the approach is a total failure and there's nothing really going on, if your P is 0.05 and you're funding enough groups, somebody is going to come up with a statistically significant response to this approach, whatever it might be, just as a matter of odds, right? Just as a matter of stats. Journals around the world tend not to want to publish studies that get negative results. Nobody says, oh, I tried to figure out whether this causes that, and I found out that after all, it doesn't. Journals think that's not very exciting. Nobody's going to read our journal if that's what we publish, and that means no one's going to advertise with us or people aren't going to subscribe to us. So journals tend to want to publish positive results. So if you get 19 people funded to take the same approach to something and they all get no results, and then you get one person who, by statistical accident, gets a statistically significant result, that's the person who gets published. Okay? So Ioannidis looks at these kinds of structural problems. There are a couple more that he mentions, but I won't go into them. But he looks at these things and he just predicts. I'm guessing that most published scientific results are incorrect. Pretty bold, but that paper got downloaded a lot because people were so interested in all of the ways that he was listing in which things could go really wrong in STEM research. And he follows this up with a paper in which he looks at, I think he originally planned to look at the 50 most cited findings in the 4 major English language medical journals. So New England Journal, JAMA, Lancet, and BMJ, I think, are the 4 that he toured through. He looked for the 50 most cited medical papers, I forget, maybe in the last 25 years, something like that. And then he eliminated one because one of them was by him. So he eliminated that for conflict of interest reasons. So he publishes this weird paper about the 49 most cited medical papers from English language journals. And he shows that since their publication, more than half of them have been contradicted by large population studies and appear to be incorrect. So basically, rather boldly, he writes one paper saying, I predict most scientific findings are wrong, and then a couple years later, he comes out with another one that says, look at all the most cited medical findings, and guess what? Most of them are wrong. And then he follows up to say, the findings that are wrong continue to get cited for years and years, especially in the specialty literature. Somebody who comes up with some really important finding or a really striking finding in, hematology, if that finding is reversed in a big population study published in JAMA, hematologists don't sit around reading big population studies about things that are published in JAMA. They read the hematology journals. And in the hematology journals, the news that this important finding has been reversed in a big population study doesn't trickle down to all of the millions of medical school faculty in hematology all around the country and indeed the world. And in the specialty journals, these findings that have been called into serious question by major population studies continue to be cited for much longer, like for a decade after they shouldn't be. Okay? So what should we do about that? That's an interesting question, and I'll get to that toward the end. Meanwhile, let me talk about another kind of problem that we have with STEM research. There's a 2020 article, it's the most recent one I could find, by the editors of the online site called Retraction Watch. Retraction Watch is a website that keeps track of and explains the reasons for retractions of scientific journal articles. In other words, when someone is discovered to have falsified their data or manufactured their data outright or selectively hidden certain unfavorable data or plagiarized, those things are reasons for retracting a journal article. And Retraction Watch has a database of thousands and thousands of journal articles that have been retracted. And very often you have to go to Retraction Watch to figure out if something has been retracted because some of the big publishers are unwilling to mark an article as retracted in their own database because they're worried about getting sued by the authors or by some of the authors or whatever. And also in some cases it's mechanically difficult, the way the data have been saved, to put some kind of warning on there that says that an article has been retracted. And in some cases they're just embarrassed. If they published an article that needed to be retracted, that reflects poorly on their own peer review process and so on. So they're unwilling to admit that or mark it. So Retraction Watch has these things. The editors of the journals have retracted these articles as meeting one of these criteria for retraction. And these are all serious ethical problems. This is not, oh, somebody accidentally came up with a hypothesis that fit their data. No, this is things people have done on purpose. Okay? Retraction Watch keeps track of this stuff. And by the way, they are linked to certain kinds of scientific footnoting services like EndNote or Zotero. If you use those and you try to cite to something that's been retracted, they will tell you. This is actually a good reason for any lab to use those commercial services. There are about 4 or 5 of them that are linked to Retraction Watch, rather than just piling up your own sites in your own computer in your own format on an app that you have, because the commercial ones are actually linked to Retraction Watch. Anyway, in 2020, the editors of Retraction Watch looked at a very large collection of articles, I think that were just PubMed published or something. And they thought that about 1 in 50, so 2%, of all published articles in STEM ought to be retracted because of plagiarism problems, data manufacturing, data editing problems, or there is another criterion, although it's not most of the problem, there's a criterion for a major mistake, just like really getting something seriously wrong. Okay? Because these guys are not in favor of retracting any article that might be wrong, right? That's science. They're in favor of retracting articles that are wrong for really egregious ethical reasons, and there's this small category called major mistake. So they're estimating about 2% of all articles should be retracted from journals, and the current retraction rate is 0.1%. They say more articles are being retracted every day, but the rate of retraction of articles in journals that have been retracting articles for many years has not changed. So what's going on is that the universe of journals is expanding, and the new journals are discovering that they're publishing a bunch of stuff that needs to be retracted. And a bunch of journals are retracting at similar kinds of rates to each other. It's just that there are more and more journals. Of course, many of those journals, part of why the retraction rate is so low is that many journals are predatory and many journals have really, really low standards. The predatory journals are the ones that will publish things if you pay them. And you could fill a very amusing paper with citations to kind of deliberately, perversely terrible articles that various scholars have had published in predatory journals. Basically, they will publish complete nonsense if you pay them enough for it. So there are lots of these predatory journals, and there are also journals that have very low standards for publication and very poor levels of peer review. My understanding that this is a bit of a problem among a bunch of Chinese published journals, Chinese English language journals, because in some schools in China, there is a fairly, they're interested in Chinese science having an impact in the world. And so they want all of their graduating doctoral students to publish something in English, because the things that are published in English get to be more widely cited, get read more around the world than the things that are published in Chinese. And so there's been this response. A bunch of the universities have said you can't graduate with your PhD until you publish something in English. And as a result of that incentive, a bunch of journals have popped up that are basically willing to publish almost anything in English, and they get paid by the authors to do this. So there's a terrible flood of bad research work out there, and you find it if you just do your research on the internet. You'll find it. And some of these journals are hard to tell from legitimate journals. You go to their websites and they list who all their editors are, but very often the editors aren't aware that they are listed on these sites. Or in some cases, the editors have just said, okay, I'll be an editor for your journal, and they're on the editorial boards of so many different journals that they don't notice that one of them absolutely never calls them, okay? So, lots of problems, lots of innocent problems because of the way science is conducted and because of the way science is funded. Lots of not so innocent problems because I think of the real tremendous pressure in the academic world to publish. Here's part of what I think is going on and part of why there is so much, there are so many problems with scientific integrity. And so many, well, there are a number of different reasons. The biggest kind of background reason is that big research universities have sharply cut back on their willingness to fund scientific research. They build, I will say, they build beautiful buildings in order to attract people to want to work in their labs. But in terms of funding the actual work, the actual salaries, the research assistants and the postdocs, the universities have basically told scientific researchers, you've got to get your funding from outside for that. We'll build you a gorgeous building, but you've got to fund yourself with government funding or private foundation funding or industry funding. Industry funding in particular has been known to give rise to lots of problems about research integrity because industry is incentivized to publish findings that are in favor of the products they create. This can be true in engineering. It's certainly true in the drug industry. It can be true in a wide range of STEM products, where industry says, where industry is incentivized to, if they find a product of theirs is successful, they'll try to publish several different studies that show that this product is successful and show it several different ways. And these things can get into journals because there is essentially an infinite supply of journals. But when they do this, one of the things that they do, there are two traditions that have been uncovered, particularly in the pharma industry, but I think they're more widely scattered around than that. Ghost authorship and guest authorship. Ghost authorship occurs when industry people co-author with university authors, but then remove themselves from the list of authors at the time of publication. They say, oh, I don't want to be given any credit for having worked on this article. What this means is that the industry origins of an article are disguised from the reader, and it appears to have been written entirely by university authors who are thought to be more objective. Guest authorship is something different. That's when industry folks in-house write an article, and of course, the article will be favorable to the products of that industry because they don't get paid to write articles that are not favorable to the product of their own industry. So they write that article, and then they will call someone in a university, on a university campus, and say, Dr. So-and-so, would you be willing to have a look at this article? And if you take a little time to cast your eye over it, we can make you a co-author. So this is not the right standard for authorship. Authorship these days is thought to require having a role in the conception and in the research and in the writing of a piece. Other people are supposed to be credited not as authors, but in footnotes that specifically mention what they have done in connection with the paper. There's also another alternative to that, which is so-called movie credits authorship, where lots of people are listed as authors, but it's very specifically listed what they did. So-and-so contributed data, so-and-so ran the program, these two people interpreted the data, this person was the main author, etc. Okay? being invited to look at something that's already been finished and make a couple of comments on it does not make you an author under any of these standards. And yet, that is what happens in these cases of so-called guest authorship. And again, what this just makes an industry-sponsored publication look more legit because it's got some university research authors on it. Now, neither guest nor ghost authorship means that the piece underlying is wrong or fabricated or false. It does mean, though, that the literature is being filled with studies whose objectivity and whose potential conflict of interest and so on can't be evaluated because there's disguising of who the actual authors are. So that's one kind of practice that leads to some of these troubling problems. And that is related to this idea that we want lots of research to be paid for by industry. Scientists often, when they're sponsored by industry, it's been demonstrated with one study after another in a number of different fields of STEM, that if your work is sponsored by some industry, you are more apt to publish work that makes that industry appear in a successful or positive light. This has been shown again and again. There are a bunch of empirical studies that look at who's sponsoring scientists' work and what kinds of papers they write. Now, this isn't shocking. Industry sponsors someone's work because they're doing stuff that they approve of. That's why they're willing to pay for it. Of course, people who are sponsored by industry are going to be publishing things that make the industry, that cast the industry in a favorable light or make their products look useful or good or advance techniques that the industry is trying to advance in the literature and so on. But here's the kicker. If you rate researchers' output by favorability to the industries that sponsor them, and then you ask them whether their judgment about what they publish or about the topics that they work on is affected by the sources of their funding, you get some very self-aware people who are like, yeah, of course, the source of my funding does affect what I do. It has to, and so I'm aware that this is happening. And you get other people who say, no, I'm objective. It doesn't matter where my funding comes from. I write what I find to be true, and I'm not actually affected by the sources of funding. If you sort researchers by where they put themselves on a spectrum from being affected to not being affected by their industry funding, and I'll bet you could all predict this, the people who say they are least affected by their industry funding are the people whose publications are most favorable to the industries that fund them. It's just sort of simple psych. They're just not very reflective about it. They're not worried about it. They think they're better than that, and therefore they're not taking any kind of internal precautions to double check their judgments or to invite some outside person to read their papers and so on. So that's another kind of problem. A third kind of problem I would like to kind of assimilate to this problem we used to have with airline crashes in the United States. There was a period back in the 80s when lots of airlines, actually there were two industries that were very worried about the sheer number of accidents, fatal accidents that they were having. One was airlines and the other was anesthesiology. Okay? And they both took exactly the same approach to trying to fix this problem. What they said was, what we shouldn't do is blame that anesthesiologist, blame that pilot. Say, oh, that pilot did a bad thing, or that pilot was too tired, or that anesthesiologist lacked judgment, that anesthesiologist wasn't paying attention. We should be thinking about the nature of the system that puts the person in the position to make a mistake. Let's stop blaming the mistake maker and start asking, why did this person make a mistake at this point? in anesthesiology, they discovered various things like different companies, when they put different kinds of anesthetic gases in containers, different companies had valves that turned different directions for on and off. So an anesthesiologist who'd been working at one hospital for a week where the valves turned down the flow of gas if you go clockwise, now this week they're at a hospital where the valves actually go the other way. And they think, oh, the patient needs less of this, and they turn it up. Why? Because there's a system in place that allows different companies and different facilities to package their anesthesia in these gas tanks that operate in exactly opposite ways from each other. Another thing, the little tubes that come from tanks of different kinds of gas had all identical plug-in prongs. So the industry changed to make it that an oxygen prong is different from a prong for some other kind of anesthetic gas, okay? And that meant that you couldn't accidentally plug in the wrong tank in the surgical suite. Airlines started thinking about the scheduling of pilots, started thinking about how much rest they were giving each pilot each week, started looking at repair systems for flights, started looking really closely at all the systems that put pilots in positions to need to make emergency judgments. And they basically started fixing their background systems. Both these industries had just absolutely spectacular success. Accident rates in the airline industry plummeted, and accident rates in anesthesiology absolutely plummeted. The other thing they did was, after any accident did happen, they put in place a whole kind of investigation structure that didn't begin with accusing the person who caused the accident. Instead, it began with interviewing that person. What happened? What were the things that went wrong? Why were you in this position at this time? And trying to address the system rather than the particular person who was at the point of this kind of systemic problem. And this greatly improves safety in both these industries. I think we have a similar system that's inducing academic misconduct in the way that we fund STEM research in particular. There is huge pressure to get grant funding. And grant cycles come along pretty quickly. And to get a renewal on a grant, or to get a grant from the same source, or to get a grant on the same topic, you really need to have published something by the time the next grant funding time comes up. There's a huge amount of pressure on labs to get things out there. And if it's, and I've had colleagues here, one in particular who's a stem cell researcher here, who has said to me, you know, I've been in the situation where it's the week before a grant renewal deadline is due, and my research is not quite finished. It's not quite ready for me to have a working paper that I could show to anyone, or that I could put on a site where I would get credit for having generated this paper. And I know how it's going to come out. I've done a lot of the basic research. I know how this paper is going to come out. And I could easily write the paper without finishing the work. Write the paper before all the data are in, and that would advantage me with respect to the grant deadline. And the only reason I don't do that is I think it's wrong. Well, that means that there are a lot of people who are in this highly pressured situation where, in order to make their own salary, they have to publish by a certain time. And think about the person who has done a lot of work in an area and who thinks, you know, again, I know how this research is going to come out. I know what the data will say. I can write a paper about data that look like that. I could make it up. And then when I finish my research, actually, it'll turn out to be that way. That kind of thing is one possible result of a process that is putting people in a situation where they really need to publish by certain times, regardless of where they are with their underlying research, in order to get funding looking forward for years. So I feel that some piece of the high rate of academic misconduct is due to the system that we're using to fund the research. And for example, a few years ago, there was the specifics don't matter. There's a Harvard researcher who had manufactured some data on a couple of projects. And a postdoc of his, or maybe a doctoral candidate who was training in this lab, wasn't aware that his boss was manufacturing the data. And he needed publications to go on with his career. And the PI in the lab at Harvard got disciplined for research misconduct and had a bunch of the papers that he had co-authored with this graduate student or postdoc withdrawn from publication. And all of a sudden, this guy's thinking, how does my career go forward? And what happened was the PI actually, although he'd been suspended from university work, actually got permission to work in his lab with the postdoc to actually duplicate the real experiments that he had made up data about and actually conduct them, and the data came out the way he said they would. He had invented the data, but the data came out the way he said they would, and then the student was able to publish pretty much exactly the same paper, but with actual data rather than fabricated data. Right? And this is a way of showing that it was probably the result of that kind of funding and timing pressure that this happened. It can be other things too. Of course, some people just want to be famous and they want to lie about amazing things that they found. Some people are trying to dupe their funders into funding them. We've seen this in Silicon Valley with people who are seeking venture capital funding. It wouldn't shock me if there weren't researchers who are trying to publish striking results in order to attract more foundation funding, for example. So what can we do about all of this? There are a few things I can think of. One is everybody should use EndNote or Zotero or whatever. Everybody should try not to cite articles that have actually been withdrawn from publication for ethics reasons. Second, and advances are being made on this, all journals should have some kind of pre-publication mechanism. This has increasingly happened with federal funding where you have to register and publish your hypothesis before you begin your research. So you can't back into your data and find a hypothesis and then write the paper about it. With federal funding, this has been happening. Foundations and private companies have not been as thorough with this, but it's something you can do. Pre-register a paper in a place where people can go look for it and say, this is the hypothesis we're going to be testing. This is when we're going to gather our data, and do all that before you start gathering the data so it can be seen that you're doing it, right? And you can prevent the mistake of backing something out of your data. More journals should publish negative results. More journals should just sort of give up on this idea that it's only advancing science if it's a positive result. If it's a negative result in a field where lots of people are getting funding to take the same approach, publishing the negative results can save a lot of heartache and prevent the waste of a lot of money. Right? If people look around and say, oh, this person is doing exactly what we were planning to do in a couple of months, and look, they got nothing. Maybe we should rethink our approach to try something maybe slightly different from what we were going to try to do. Right? Those kinds of things. If we published more negative results, that would be great. I feel like part of every student's doctoral candidacy in STEM should be a requirement to try to publish a paper that duplicates someone else's results. Right now, right, science is supposed to proceed by people duplicating the good results and not being able to duplicate the bad results. But people don't go out there and try to duplicate other people's results because it is not commonly rewarded by journals or by funders. What's your project? Well, I'm trying to see if I can make the same thing happen that that guy at Stanford made happen last month. That's not an exciting project, but that's how science is supposed to advance. Ideally, a bunch of people who try to do that will discover that they can't. And then people will think, oh, maybe it was just an accident that that guy at Stanford got that result. Maybe it was a statistical anomaly. Maybe there's something wrong with his data set, right? So I feel like every doctoral program should make it the responsibility of new people who are just getting into that level of research to try, to pick some exciting new result and try to duplicate it. Talk to that corresponding author, get their data set, or ask them exactly how they gathered their data. Try to make the same thing happen. If you succeed, that's maybe a letter to some journal editor saying, guess what, I was able to duplicate so-and-so's results. If you fail, that might be an article that says, this finding, very questionable. Right? All those kinds of things would be very useful. There are some useful online lists of predatory journals. It would be good if people avoided predatory journals. But again, they're responding to incentives to publish. They're desperate to get something published, and they're willing to pay to have it published because their university won't let them graduate unless they do, or because they won't get funding unless they do, and so on, or because they're worried they won't get promoted unless they do. That's why these predatory journals have a business model. So I guess the final thing that I would speak in favor of is trying to build and spend more kind of research university endowment on funding scientific research in-house and not entirely from outside sources. There's been a big move of the university model to get people to raise their money from grant writing. At our medical school, the medical researchers basically raise their entire salaries from grant writing. I think our School of Public Health says 80% of salaries have to be raised through grant writing, and the 20% is to make sure you're teaching your courses. You get salary for 20%, but over an average, over a certain period of years, you're supposed to hit this target of 80%. Here on Science Hill, a bunch of the labs with biomedical researchers, it's not quite as extreme as 100%, but it has been moving in that direction. There's more and more pressure to get outside and industry funding for labs. And some things, like postdocs and research assistants, you can only get with outside money in many circumstances. I can't speak, I don't know deep details about this, but my general impression is that research universities around the country are ceding funding for research to outside bodies. And the pressure to get that funding, I think, is part of what is leading the epidemic of research misconduct. I don't think I quoted this statistic before, but when these guys at Retraction Watch look at the total number of retractions, it is the clear majority, it's in the high 60s, 67 or 68%, something like that, of retractions are caused not by somebody realizing they made a terrible mistake and asking that a piece be retracted. They're caused by ethics offenses like plagiarism and data manufacturing. Okay? So it is a very serious problem. And I've articulated what I hope are a few ways that we might start to combat it. And I now have about 10 minutes before I have to run away. So I welcome your questions or your comments or your responses. Yes?
Hi, I'm Gideon from BU. I wanted to ask, so you've been talking mostly about the medical field and scientific field. Do you know if similar patterns apply in social studies and humanities?
There's been, in social studies, especially some kinds of social sciences, like there's been a real problem with inability to reproduce results in the psych literature, for example. In humanities, a lot of humanities research is not a matter of mobilizing data. So lots of these kinds of questions don't really apply there. A lot of the debate about the quality of humanities research is about how much of that research is over-informed by certain kinds of ideologies. There's also, of course, there's questions about funding in humanities research. The huge one came up when we had this big not Bitcoin, another one of the currencies that where the top guy just was arrested. He was in the Bahamas or something, and anyway, that what's the initials for the company? Do you remember? Attendees. Yeah. Okay. That his group was funding a bunch of philosophers who are these long-termist ethical theorists. And long-termism is it's usually cast, Will McCaskill says he's not a utilitarian, but it's usually cast as a kind of utilitarianism that thinks that the consequences we should be thinking about should be at least 500 years out. We should be, when we're thinking about what the best thing to do is, we should be thinking about consequences for humanity hundreds of years out, which means that we should be particularly concentrating on existential threats to human existence, like some asteroid that might come and hit the Earth. We should be really putting a lot of money into asteroid defense, and frankly, a lot less into worrying about climate change, because humanity will probably survive climate change. It might be quite disturbing, but it's not an existential threat to humanity. At least some of these guys say this. And they're very interested in colonizing space, because they think if we can colonize space and make lots and lots of humans live on planets all around the universe, and also if we can combine ourselves with AI and make lots of kind of immortal human-like creatures that have full moral status of humans and whose pleasures and pains would count in a utilitarian calculation, then we're looking at the welfare of bajillions and bajillions of possibly extant people on planets everywhere. And that means that outweighs, that potential benefit outweighs tons of present stuff, okay? Who's funding these guys? I don't know. Think about people who are interested in colonizing space and have a lot of money to throw around. And own Twitter. Okay? I mean, there's a lot of money flowing from a lot of different sources to fund this kind of thought, including buying multi-million-dollar buildings for them outside Oxford to have university research centers. Okay, so there is such a thing as corrosive private funding in the humanities. I have to say, there's a bunch of really legit long-termist thinkers. What I've just said is sort of the most extreme version of it, but those guys are attracting money. And whereas, you know, people who are working in other philosophy-related fields are not attracting the money of very wealthy investors. So there can definitely be agenda-setting funding in the humanities sector in the same way that there can be in the natural sciences and STEM. Social sciences, there's also, of course, there's lots of social science fundings for questions about really hot social and policy issues. And that funding can also be corrosive. And my feeling just generally is that people who aren't under pressure to gain funding for their research will do more objective research, or at least do research that's in line with their own internal compass and not be corroded or threatened by it. The thing about social science, though, is that and humanities at universities is though there is this corrosive effective funding, most folks aren't under the pressure to grant write their salaries in social sciences or in the humanities. So you don't have the systemic kind of problem that the STEM world faces. people in the sociology and the anthropology departments, they get grants to do field studies and things, but they don't have to grant write their salary in the same way that people in the natural sciences do. A different kind of bad side effect of that is that a bunch of universities and a bunch of colleges are choosing to have their courses be taught by adjuncts rather than by full-time faculty, because they are paying the salary. They're not making them grant write. But in order to pay less, they're willing to string along someone after their PhD being a lecturer or an adjunct, teaching course after course after course and never giving them tenure and never giving them full salary. That's been happening in the humanities and the social sciences increasingly, and that's another kind of disturbing trend. Someone else? Yes, in the back there.
I'm Arbery, engineering by engineering. I found it interesting that throughout your presentation you didn't use the word innovation at any point. And from a perspective of the audience, so the public, is it really bad if we equate pressure to publicate journals or product articles with innovation? What do you feel about that?
Certainly, innovation reaches us by being published most of the time. And everybody thinks that scientists should innovate and be inventive. The question whether they should be paid by their universities a salary to do that, or whether they should be paid by a private firm to do that, is a different question than whether they should do it. And private firms are looking for specific kinds of innovation. If you look at the history of medicine from, say, World War II to about 1970, everything got invented in medicine then, right? Antibiotics came online during the war and became widely available after the war. That caused all kinds of innovation in surgery, cortisone, positive pressure ventilation, the invention of the ICU, the separation and storage of blood, all kinds of transplant, the invention of most of the really major early vaccines for polio and influenza, the invention of long-term effective birth control like the IUD and the pill. It's all in these 20 years after the war, and it was pretty much all university-funded and not privately funded innovation. So it isn't the case that private money makes innovation happen faster than university money does. So, yes. Sorry, you had your hand up earlier. Yes.
Yeah, my name is Shanti. I go to MIT, and I noticed I don't know if it's a trend or it's always been there, but a lot of principal investigators of biomedical science labs, which is where I do my research, also are creating startups or biotech firms with the kind of research that they do. And although a lot of the times that's not funding their research implicitly, I think that it shapes a lot of their research directions and goals, and maybe encourages them to pursue a certain direction of research if they can create a product out of it or some diagnostic. And do you think that that's a problem? And if so, how do we fix it, or is it just kind of a byproduct of?
So this is actually another question about incentivizing innovation, right? When researchers discover something at any university while they're working for the university, it belongs to the university. MIT has patents on all the things that those people invented. When social scientists invent a new instrument to find out whether people are biased in certain ways or whatever, those things are patented because they are, or they're copyrighted, depending. And the universities usually own those patents and those copyrights. Yale owns all publication rights to anything that I write in the first instance. But what do they do with that? Well, they cede a lot of it to me. They usually retain the right to say if they wanted to separately publish something in a little journal called Things Our Faculty Published This Year, they can do that. They retain some kinds of rights. They usually retain some parts of patents from things that came out of engineering or come out of bioscience. They retain some part of that and make some money from it, but they usually give a big chunk of it to the actual PI, the actual inventor, so that that person can use it to make money by forming one of these spin-off companies or using it in their work in some other way. And that is a way to incentivize innovation. This is not an outside firm telling a researcher what to do. This is a researcher finding something that's really useful and then being allowed to benefit from it. And patent law itself is kind of that way. If you invent something, if you arrange matter in a novel way that's useful, then you have a monopoly right to sell it or license it to people for a period of time, and then your technology has to go public and has to belong to all of us usually after 21 years. Why do it that way? Because that incentivizes innovation. So I actually don't think that that is terribly bad. It can have the bad effect of drawing university scholars kind of out of the university world and making them concentrate entirely on the things that make them profit. But that is something that I think universities need to handle on a kind of personnel level. Whereas I think permitting researchers to make money from things they invent incentivizes innovation. Yeah.
Hi, my name is Crochet. I'm from Cornell. I kind of had two questions. The first one is about the predatory journals that you discussed.
Yeah.
I was wondering if they tend to have low or high impact factors. And then a second
They have low impact factors.
Yeah, low. Okay. The second question was about a possible solution. Like, what do you think about cutting down on the number of journals? And if so, how could that be done?
Yeah, I don't know how you could cut down on the number of journals. Certainly universities can decide which journals they will subscribe to in their big electronic databases. And if enough major research universities just decided that they were never going to subscribe to certain journals that were on the predatory journal list, that would even lower their impact factors even more. And that would mean that getting published there might not help people's careers as much as they would want, and so on. So that might be a tactic, is just to try to prevent institutions from giving you access to journals through your library. That doesn't do anything about if you just Google, or if you go to Google Scholar and find something. Then maybe you'd have to get cooperation from search engines to try to help people stay away from predatory journals. I don't know how that would work. Certainly universities could adopt policies about, for example, what you're allowed to cite. You're not allowed to cite anything that doesn't appear in this or that online collection of journals or something. But yeah, but the good news is they do tend to have low impact factor because, just because people don't want to read stuff that's got a lot of low quality content. One last question, because then I have to run. Yes.
My name is Madeline. I go to the University of Virginia, so I have a question kind of from a public school standpoint. So, from what I understand of your talk, in order to get less away from relying on grants, we, for instance, would need more money from the state to pay our faculty. And I think in Virginia, we would have a hard time convincing our governor that UVA needs more money for STEM research. So how do you see these principles of open science operating in this political climate where science has been so politicized and is kind of controversial?
Yeah, that is a really hard question. And yeah, I don't really have a good answer to that. I look at the travails that some of my friends in bioethics and, more importantly, many of my friends in the humanities are going through at a lot of big state institutions where funding is withheld, is being withheld because of allegations about the political content of humanities research of various kinds, and stuff that I think of as kind of tame, as being condemned as crazy left-wing in some places. There's a lot of ideological conflict about humanities in particular. I would say in particular history, and then some of the subfields in humanities that are something studies, right? Women's studies, minority studies, indigenous people studies, those kinds of humanities programs that are usually a mix of history and political theory and some social science. Those are really under attack all over the place, and I don't know how we could rely on the universities to fund all that work in that political atmosphere. And similarly with some kinds of science and some kinds of medicine. I think we're in an era where university funding, especially as you say, in the public schools, is not, might not be forthcoming. And then the question is, will the university permit people who want to do that kind of work even to get private funding for doing it, or to get NIH funding for doing it, or will the university simply say this kind of research is off limits to people who want to work here? I don't have a good answer.